Good Monday morning. Okay, we're going to do 3.5, which is our last lesson of the chapter. Remember, we're going to have a test on Thursday. This one is graphing linear relations by hand. And if you haven't done the Minds On already for 3.5, please pause the video and do that now. All right, so today's learning goal is to graph a line given an equation using a particular method called the slope y-intercept method, and you're also going to graph a line from a real world problem. All right, here we go. So the Minds On says graph the points a14 and b3 -2 and determine the equation of the line. All right, so I'm going to start at the origin. I'm going to graph 1, 4, so I'm going to go over 1 and up 4. And that's this point here about, oops, I don't know why it's not happy there. So this is the point 1, 4. And then I'm going to go over 3 from the origin again and down 2. So here I go. And then I'm going to draw a line and join these points. Now I'm going to use my line tool. It may or may not work. And I am going to deliberately extend my line past the y-axis. Okay, so now I'm going to put arrows. Oopsie, I should have made it black. Oh well. And I've got those 2 points, remember, right here and here. Now that I've drawn the line, it's super easy to get the equation of the line. You know how to get the slope, right? The slope is just, all right, count down from that point and count over. So how many did I go down? 1, 2, 3, 4, 5, 6. And then I went right 1, 2. So slope would be down 6, right 2. So the slope would be -3. Now what else do I need for an equation of a line? I need the y-intercept. And I can see that my graph crossed the y-axis at y equals 7. So I know my y-intercept is 7. So if I wanted to write the equation of the line, I just put it together in y equals mx plus b form, and it would be y equals -3x plus 7. Okay? Not too difficult. Alrighty, so let's get started with the lesson. Okay, so to graph a line given an equation, all you need to do is start with the y-intercept. You're going to graph the y-intercept, and you know how to find the y-intercept when you're given an equation. It's the number without the x, if it's in y equals mx plus b form. And then what you're going to do once you graph the y-intercept is you're going to apply the slope to that point to get yourself to another point on the line. And then you've got 2 points on your line, you just join them. Okay? All right. And then, of course, you have to label, and we'll talk about that in a second. Here's an example. You want to graph y equals 2/3 x plus 1. Well, we all know then that the slope, the m, is 2/3, and the b, the y-intercept, is 1. So I'm going to start by plotting the y-intercept. So that's the point 0, 1. And it's just on the y-axis, right? So there's the origin, and I'm going to go up 1. So that's one of my points on my line. And now I know the slope is 2/3. And so from here, what I'm going to do is I'm going to start again with my rise, like I always did when I was figuring out what the slope was. I'm going to go from here. I'm going to start with my rise, which is up 2, and then right 3. And then I stop there, and I'll just draw another point. So the critical thing here is that you're not starting at the origin when you're applying your slope. You're starting at the y-intercept. That's very important. All right, so now I would just join my points, and I'm going to go ahead and do that with the slope tool again, or the line tool again. So there, not as good this time. I'm a little off. So I could kind of just try and rotate that a bit. Okay, that's a little better. And when you are graphing a line, what you have to make sure is that your line goes past your 2 points. You're going to put arrows on either end, and you're going to label those 2 points. So this was the point, I don't know. I know this was the point 0, 1. But this point I don't know. It's not the point 2, 3, which is a very common mistake. What I have to do to figure out the coordinates of this point is go back to the origin and actually count over. So I'm going to count over 1, 2, 3 on my x and 1, 2, 3 up on my y's to get there. So it's the point 3, 3. Okay? One thing missing on this graph is the equation, and you put that at either end of your line. Okay, so how do we do it? We plot the y-intercept, we apply the rise and the run, we join our points, arrows, 2 points, and the equation. That's full marks. All right, let's let you give it a try. Okay, so I want you now to pause the video and try to graph y equals negative 5/4 x plus 3. Feel free to rewind the video anytime you need to go back to see how I was doing it. Alright, so let's graph y equals negative 4x plus 3. So this is going to have a slope of negative 5/4. It's going to have a y-intercept of 3. Now this one was a little tricky because of the negative. So remember, you have to apply the negative either to the top or the bottom, but not both. So this again was the point 0, 3, my y-intercept. Go to my origin and go up 3. And now from there, I am going to apply my slope. So my rise was minus 5. That means I'm actually going down 5. So 1, 2, 3, 4, 5. And then I'm going to apply the 4. And that's positive, so I'm going right 1, 2, 3, 4. And now I know that if I join these 2 points, I should have a slope that's negative. And it does look like that line would be sloping negatively. All right, so now we're going to go ahead and join our points. I'm going to put arrows on the end. And I'm going to label, this point was 0, 3, I knew that one. And this one I didn't know, so now I'm going to figure it out. I have to go over 1, 2, 3, 4, and down 2. So 4, negative 2. Okay, so unlike rise and run, rise meaning y's, run meaning x's, you do the rise first and then you do the run. Not so for when we're ordering or coming up with the coordinates of an ordered pair. It's always x then y, right? So from here to figure out the coordinates, I would go to the right first and then down. So I know that's a little confusing, but try and differentiate between those two. One's for slope, one's for the coordinates. Okay. Did you get it right? Wait a minute, what did I forget? I forgot to write the equation at the end. All right, so there's the graph of y equals negative 5/4 x plus 3. Let's move on. So we want to graph y equals x minus 2. My slope is just 1, and my y-intercept is negative 2, which means I'm graphing the ordered pair 0, negative 2. Now this one's a little bit tricky because what's my rise and my run? I've only got one number here for my slope. So don't forget what I told you. Every whole number can be rewritten as a fraction with a 1 on the bottom. Okay? So now I know my rise is 1 and my run is 1. Okay, so let's go ahead and plot the y-intercept. So we start at the origin and we go, not up, we're going down 2. And now I'm going to apply the slope of 1. That means that I'm going to start here, I'm going up 1, and I'm going right 1. I'm going to go ahead and graph this line. Then I've got my 2 points. I'm going to join my points. I'm going to extend it past the points, arrows, label those points. So this is 0, -2. And this point here, if I go back to my origin, is 1, -1. And I need to put my equation on there, y equals x minus 2. Okay, so now it's your turn. I'm going to get you to graph y equals -4x. So go ahead and pause the video now and graph y equals -4x. Okay, let's see how you did. We've got a slope here of -4. And my y-intercept, this was a little bit tricky, but my y-intercept is 0, right? Because there's no number here after the x. Okay, so if my y-intercept is 0, that's the ordered pair 0, 0, better known as the origin. So that's one of my points on my line. And now I know that -4 can be written as -4 over 1. So my rise is -4 and my run is 1. So from here, I'm going to go down 4. 1, 2, 3, 4. And I'm going to go to the right 1. Okay, and then I'm going to join my 2 points, draw my line. I'm going to put my arrows on, label my points. So this is the point 0, 0. And this is the point, start at the origin, over 1, down 1, 2, 3, 4. So 1, -4. Don't forget the equation. Okay, hopefully you got that right. So that's really all there is to graphing lines given the equation in y equals mx plus b form. Okay, it's called slope y-intercept form. Okay, so the next example is a real world example. An online movie company charges a fee of $4.50 for a one-day rental, and then every day after that is 75 cents extra. So the first part of the question is create a graph of the linear relation that models the total cost to rent the movie for the first week. So what we've got here is we've got a flat fee of $4.50 for one day. And then every day after that costs a little extra, right? 75 cents for every extra day. So what we're going to do is we're going to let our x-axis be represented to represent the extra days, or the number of extra days the movie gets rented for. And then the y-axis will represent the cost in dollars. Okay, so let's review. It said at the top here, it said $4.50 for one day and then 75 cents extra. So if they just rent it for the one day, I know that's looks like we should start there, but that's the number of extra days, remember. So one day, $4.50. That's like our y-intercept. And then if you notice the scale here, this is 0. So the scale here goes up by 75 cents. So I'm just going to go up 1 square and over 1 square to represent the cost for the first extra day. And that's going to continue in that same fashion, up 1 over 1, up 75 cents over 1 extra day, until we get to 7 days. And then after 7 days, that's the first week. So we have graphed the cost for the first week of rentals. We're not going to put an arrow here on this end because we can't have negative extra days. And it only asked us to graph the linear relation for the first week, so we wouldn't put an extra or an arrow there because it just wanted us to limit it to the first week. So That's my graph. I'm probably going to label 2 points. So let's label the first point. Oopsie, sorry. 0 and 450. Ignore that little line to the left there. And the next point, we could label any of these points, but if I go ahead and label this one, this is the 7th day, and it looks like we're at 975. Okay, so that's good enough for part A. Part B says write an equation that models the costs for each day the movie is rented. Well, I'm going to say y equals mx plus b, and my y-intercept is 450, and my slope was going up by 75 cents every time, right? So that's going to be y equals 0.75x plus 450. How much does it cost to rent the movie for 2 weeks? Well, I'm going to extend my graph now and hope that I have enough on my y-axis to get me to where I need to be. So if I choose did I use a line tool? I can't remember now. I don't think I did, so I'm just going to go ahead and graph this, and I'm going to extend this line till I get to 14 days. That looks pretty good. Let's see what I got there. Okay. And what am I at? It looks like I'm at almost at $15. And I'm going to say I'm at $15. So I'm just going to look at this point here. This is the point 14, and then I'm up here. It's close to 15. So I'm going to say, how much does it cost to rent the movie for 2 weeks? I look, oh goodness. Sorry, I'm on my line tool. I look at my graph and I estimate it costs $15 or about $15. Okay. And how many days can the movie be rented? With $13.50. So $13.50. I'm going to go to my y-axis. I'm going to go to $13.50. Again, I'm just going to use my little line tool here. And I'm going to go all the way over till I get to my line. And then I'm going to look down, and I'm going to see that I'm at, it's hard for me to tell here because my graph isn't showing. Oh, it looks like it's 12 days. Okay, so I just sort of interpolated from my graph once I extended it. So I'm going to say I look at my graph again, and I estimate I can rent the movie for 12 extra days. And that's all she wrote. Okay, so can you please do your consolidate for 3.5, sorry. And you're going to do your classwork or textbook work for 3.5. I'll write that on the board. And we have a test on Thursday. We'll be reviewing for the next couple of days. But make sure you do your textbook work, please, for 3.5. This is where it gets difficult, right? When you have the real life word problems, they can be challenging. And graphing is not, it's not everybody's favorite. I understand that. So it does take some practice, though. All right, get to work. Thanks.